Now let's talk about optimization. We always use optimization in context such that when I'm running a company and I want to find the maximum revenue, the maximum revenue is, in this case, is considered to be the optimum value, which is the best value for the company. Moreover, if you have your own business and you want to find the minimum cost, the minimum cost in this case is also considered as the optimum value. So let's see what's optimization and how we can use differential calculus to optimize our functions. Let's draw a curve now. This is my curve. Continuous and continuous. Now on my curve, this point is called a local maximum point, and this point in here is called a local minimum point. If we want to find the gradient of the tangent at these points, let's draw some tangents on these points. Let's draw a tangent on this point. And let's have another tangent here. You can realize that this tangent and the other tangent is a horizontal line. And the gradient of the horizontal line is always equal to 0. So by this, we can conclude that in order to find the coordinates of the local minimum or maximum points, we need to first find the first derivative, then we need to make the first derivative equal to 0. Why is that? Because the gradient of the tangent at that point is 0 because it's a horizontal line. Let's have an example from the IB question bank now. I have a cuboid, has a rectangular base with width x and length 2x, and I have the height to be h centimeters. The total length of the edges of the cuboid is 72 centimeters. Then here the volume of the cuboid is expressed as v equals ax squared minus 6x cubed. For part A of the question, we need to find the value of A. So for part A of the question, I need to find the volume in this formula. So now, the volume is simply equal to the length of the base times the width times the height. So it's equal to x times 2x times the height, which is h. So now the volume is equal to 2x squared times h. As you can realize, it does not look similar to what we have in here. So we need to use the givens in our question that the length of all edges is equal to 72. The edges that we have, I have this is h, this is h, this is h, and inside there is h. I have 4 h's. Also this is 2x, 2x, and I have at that side 2x. I have also for 2x's, and for the x it's the same. And the length of all the edges is equal to 72. So I can start by having 4 times x plus 4 times the 2x plus 4 times the h, and this will give me 72. So now expand. I have 4x plus 8x is 12x plus 4h is equal to 72. Let's now make h the subject of the formula. I have 4h to be equal to 72 minus 12x. Now to make h the subject of the formula, I have to divide both sides by 4, having h to be equal to 72 divided by 4. I go to the run matrix. I'll use 72 divided by 4, and this is equal to 18, minus 12 divided by 4, 3x. Now, I take this value for h and I substitute it in the volume equation in here. So I have the volume to be equal to 2x squared times h, which I substitute 18 minus 3x instead of h. So I have the volume equal to 36x squared minus 6x cubed. So now you can see that this equation in here is similar to this one. It's 36x squared minus 6x cubed. Here we have ax squared minus 6x cubed. So we can realize that the value of a is equal to 36. So by this, we found that the value of a is equal to 36. Let's do part B of the question. For part B, we need to find the value of x that makes the volume a maximum. To make the volume a maximum, we need to make dv over dx equal to what? To 0. Now let's find the first derivative. 2 times 36, it gives me 72x. 3 times minus 6, it's minus 18x squared is equal to 0. Now to find the values of x, this is a quadratic equation. Let's just rearrange our quadratic equation. We'll be having minus 18x squared plus 72x to be equal to 0. Now we'll use our graphical display calculator. We go to menu and we go to equation. In the equation, I'll choose polynomial because this is a polynomial, and degree of 2 because it's squared. A, which is the coefficient of x squared, is minus 18. B is 72. And the value of C is 0 because I don't have any constant, and I execute. I'll have x1 to be equal to 4. And the value of x2 is equal to 0. The question wants the value of x. And the question contains the volume and lengths. So can be x equal to 4? Yes, it can be equal to 4. Can x be equal to 0? No, because no length of any side can be equal to 0. So in this case, we reject this value and we take the x value to be equal to 4. So this is my answer.